Hi guys, this is Miss Scott. So here we'll start with your bad joke of the day before we get started. Now I don't want to date myself, but I have not actually seen a Fast and the Furious movie since the first one came out when I was like in high school. Um, but so if they're past Fast and the Furious 10, I'm sorry in advance, but the joke is still funny. What's the Fast and the Furious 10 going to be called? Fast 10, your seatbelts. That's a good one, I think. All right, well, here we go. Section 6.2 is about setting up proportions to solve geometry problems. So we're going to use those proportions that we solved in the last example, but now our last lesson, but now we're going to look at some more geometry-based questions. So your essential question, if you want to pause and get that written down, is how do you calculate actual distances from a scale drawing? Okay, also you can jot down these three statements. So we're going to look at different properties of proportions. So they all start the same way. If you've got A over B equals C over D, if you've got A over B equals C over D, and then A over B equals C over D, we're going to see what's true of these three properties here. So first of all, the reciprocal property just tells you can flip those. The reciprocals are equal to the original fractions. So we can say that B over A is equal to D over C. All right. The interchange property lets you flip-flop these two or exchange or interchange those, and you're still actually going to get an equal proportion. So you can exchange, actually let's do this in green here. You can exchange and have A over C is equal to B over D, and that is still a true proportion. All right. And then the last one is the add up property, which lets you take the denominators and add them to the numerators of each fraction. Okay, so if we add in the top, if you add A and B and keep it over B, that's going to equal C plus D, and you keep it over D. All right. So we're going to use those to make three true proportions from this original proportion. Okay, so if we use the reciprocal property, we are just going to simply take these and flip them, and they will be the same. They will still be a true proportion. All right, so the first one, we just flip 15 and 4, and then we flip 75 and x. Okay, so that is still going to be true. And one way I look at it is, notice if I cross multiply, I still have 15x equals 4 times 75. I still have 15x equals 4 times 75. So that's why you can do that. Notice that the cross multiplication is still equal. All right, let's look at the interchange property. So remember, that's when we can flip these two, the 15 and the x. So we're going to say 4 over x is equal to 15 over 75. All right, and again, notice if I cross multiply, I still have 15x equals 4 times 75, so it's still a true proportion. All right, if you cross multiply and get the same thing, it has to be true. All right, and the last property, the add up property, is going to let us take these denominators and add them to the numerator. So we will have 4 plus, let's just start with 4 on 15 equals x over 75. So we're going to take the denominators and add them to the numerators. So here we're going to add 15. Here we're going to add 15. Actually, we're going to add 75. So we add that fraction's denominator. So we can simplify this a little bit. 4 plus 15 is 19 over 15. We can't really do anything with that second fraction, so we'll just leave it as x plus 75 over 75. And that would be our answer. Okay. And I know if you're looking at this, you're saying, well, that's not going to be the same if I cross multiply. Well, if you do 15 times x, you still get 15x, and then 15 times 75, and then that's going to equal 19 times 75. Once you subtract that 75 times 15, this and this, you will still end up with 15x equals 4 times 75. So it does work, it's just a little harder to see. Okay, so let's look at these three examples, kind of the same idea. Complete the statement and name the property that was used. So it's going to be one of these three properties from above. Okay, so looking at this first one, I notice that the 9 stayed the same and the 9 stayed the same in this first fraction. But the top turned into 17. Well, to turn the number into a different one, that one is going to be using that add up property. So if you notice, if they added 9 here, we would get this 17 that they have. So we have to add y, that fraction's denominator, to the numerator. So what goes in the question marks would be x plus y over y. Okay, so that's the completed statement. The property that they're using there is the add up property. All right, let's look at example 5. So in this one, we have 12 over 7 equals x over y. Well, notice that they flip-flopped the 12 and the 7 to come up with 7 and 12, so this is the reciprocal property. So if we flip-flop the x and the y, it will turn into y over x, and that is the reciprocal property. So if you're just flipping it and doing nothing else, that's what property you're using. All right, so you can probably guess that the last one is going to be the property that we have not used yet. Notice that the x is now under the 3 here. So if the x is under the 3, they must have interchanged these to do that. So if you interchange the x and the 10, the other fraction is going to become 10 over y. And that is our interchange property. Okay. So just a little practice with what those look like. All right, so now we're going to move into some more geometry-based questions here. This first problem, we have that AB to BC is 3 to 8. So this is in a ratio of 3 to 8. And we're trying to figure out what the actual distance from A to C is. So let's call from B to C x, because we know it's not actually 8, it's just in the ratio of 3 to 8. We know the actual distance from A to B is 426. So if we start with this ratio of 3 to 8 and set it equal to the actual lengths, which are 426, and then this unknown x, then we can go ahead and cross multiply. So 3 times x gives us 3x. 8 times 426 is 3,408. Go ahead and divide by 3. Let's try that again. 3,408. Divide both sides by 3, and we end up with x is equal to 1,136. All right, so if this length is 1,136, to find the length from A to C, we can just add 426 to 1,136, and we'll get 1,562. Okay, let's do another problem involving a scale. So we have this 3D scale model of the Tower Bridge of London. And the towers on the model are 9 inches tall. The actual towers are 206 feet tall. And the walkways are 140 feet high. Okay, so the first thing we're going to do is figure out what the scale is. If I'm looking at And usually with a scale, it's 1 to something. So if we start with this 9 inches, we know that 9 inches is equivalent to 206 feet. And the reason we know that is that's because the height of the towers in the scale is 9 inches. The actual is 206. So to find a scale, you do the model to the actual. Okay? So this is the model to the actual is 9 inches to 206 feet. And then we simplify that. So we always want it in a ratio of 1 to something. So this means that 1 inch represents 206 divided by 9 is about 22.9 feet. Okay, so that means in this scale, if you have 1 inch of height or width or whatever, that's about 23 feet in real life. All right, now we're going to look at how high should the model's walkway be. Well, we are going to set up a proportion for this. So we have 9 inches to 206 feet, and we want to know what the model is unknown over the actual. Okay, so we have everything set up proportionally. So if we cross multiply, we get 206x is equal to 9 times 140, which is 1,260. And if you divide by 206, we get about 6.1, and that would be inches. So that would be this distance right here. These walkways would be about 6.1 inches if you measured them on the scale or on this diagram. All right, so let's look at one more example. So if you flip to the next page, it tells us that if you have this distance here from Pittsfield to Leeville, some interesting names there, is actually 24 miles. So to find a scale, again, you do what's on the map or what's in the diagram over the actual. And then you always want this to be 1. So you always want that unit to be 1. Okay? Whether it's 1 foot, 1 inch, 1 centimeter, whatever your scale is. All right. So we know, if we look on the map, because we know the actual distance from Pittsville to Leeville, and if we look at, if we would measure this, so if you have a ruler, go ahead and take it out. If not, this is 1, 2, 3, 4, about 4.7 centimeters on the map. So if we put that here for the map over the actual, well, they told us that it's actually 24 miles between those two cities. And we always want what's on the map to be 1. So if we divide the top and the bottom by 4.7, we'll turn that into 1 centimeter. So that tells us that 1 centimeter is equivalent to whatever 4.7 divided by, or 24 divided by 4.7 is, which I plugged in is about 5.1 miles. So that means for your scale, which you always see a scale in the corner of the map, 1 centimeter is equivalent to about 5.1 miles. All right, so this would be our scale in this map. And you could use inches. I just think centimeters are a little bit easier to measure. Okay. All right, so now we're going to actually go ahead and do that for these other sides. I measured ahead of time, so I'm not just like guessing these. I'm actually measuring. We're going to find the distance if we were going to fly from Leeville to Northvale, and then from Northvale to Mint Falls, and then from Mint Falls to Pittsfield. So we're going to kind of go all over the place here. First, starting with Leeville to Northvale. So I measured this ahead of time, and it turned out that this was about 3 centimeters here. And then they're going to go to Mint Falls, and again, I measured this earlier. This was about 3.4 centimeters. and then they're going to fly to Pittsfield, which was about 2.9 centimeters. All right, so if we just add up the centimeters that we have 3 centimeters, 3.4 centimeters, and 2.9 centimeters, and that adds up to 9.3 centimeters. Well, we know that 1 centimeter is equivalent to 5.1 miles. So if we use our scale from earlier, we can just take 9.3 centimeters times that 5.1 miles to get our answer. And if you do that, you'll end up with about 47.43 miles. And I would think that seems pretty reasonable because if you remember, this distance from Pittsville to Leeville was about 24 miles, and we're going quite a bit further because of all this zigzagging that we're doing. All right, well, I appreciate you guys tuning in. Let me know if you have any questions or comments down below, and we'll see you guys next time. Take care.